Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 6, Atomic Structure and Periodicity, Part 1. So we've already covered Chapter 7, no matter which year you took Chemistry 10HH. We covered the atomic structure portion of that chapter. We haven't talked about periodicity, so it's really just periodicity. Here are our objectives for this video. Pause here. So we're going to be talking about periodic trends in this chapter, which another way to think about it is periodicity. So these are trends of behaviors as a result of placement on the periodic table, or more the other way around. The placement on the periodic table has to do with these common trends in behaviors. So we're all already familiar with the periodic trend of electronegativity. So in short, things that are closer to fluorine are going to be more electronegative. And we're going to be talking about 3 other periodic trends in this chapter. Pause here. The first trend that we care about is ionization energy. So to ionize something means to either remove or add an electron. Here we're going to be talking about remove. So ionization energy is the energy required to remove an electron from a gaseous atom or ion. And something that has a very high ionization energy means that you need to add a lot of energy to remove it. Pause here. You don't need to draw the periodic table in that much detail. So the ionization energy is going to increase down a period, meaning a row. The reason why that is true is because there are more charged particles in the nucleus that are creating a force holding those electrons in. And then ionization energy is going to decrease down the group. The reason why that happens is because of a phenomenon called shielding, where core electrons actually block some of the charge from the nucleus to the valence electrons. Pause here. So this should seem pretty straightforward, but the reason why I am harping on this is because the most common way that that we talk about ionization energies is talking about multiple ionization energies. So the first ionization energy is the energy needed to remove one electron or to produce a +1 cation, whereas the second ionization energy is the energy required to remove one electron when one has already been removed. So the ionization energy to create a +2. And this could continue on 3rd, 4th, 5th, 6th, so on and so forth. It should get increasingly higher and higher. Pause here. I'm going to say the answer out loud and then I'm going to explain the reason why. The best answer here is C for aluminum. The reason why I say that is because we see how the ionization energies get higher and higher and higher, but there's a huge jump between the 3rd and 4th ionization energy. What that tells me is that whatever element X is only has 3 valence electrons, and then it requires a tremendous amount of energy to remove an electron from the core shell. So that is why C is the best answer to example number 1. Here are our practice problems for this video. Thank you so much for watching and have a great night.